All right, let's continue with chapter 5. This section is called factoring trinomials. This is going to be a pretty important section here. Factoring trinomials when the coefficient of the second term is 1. This is the sunshine and rainbows, easier problems. When we start factoring trinomials when the coefficient is not 1, things get a little bit more interesting. And there's a couple of methods that you can use to factor those, and I will show you both of them. And then there's this idea that's factoring by substitution. I won't hit you guys too hard with these. This is more for students who are going to continue on their math journey, whether they're going to take pre-calc or calculus and things like that. It's a really important idea in calculus. Not so much for algebra. Yeah, it's useful for sure, and I'll show you when you can use it. But if you're kind of taking this course as part of a program or something like that, you probably won't use this too much going forward. All right, so this is pretty critical. So we have this ax squared plus bx plus c. This is standard form of a quadratic. Okay, so this is standard form of a quadratic. We've already seen standard form of a linear equation, which was ax plus by equals c. This is just standard form of a quadratic. It's not a quadratic equation because it's not there's no equal sign. We'll talk about that a little bit later on in this chapter. But right now, this is standard form of a quadratic where a is the coefficient of your x squared term, b is the coefficient of your x term, and c is your constant as usual. Okay. So in order to factor these quadratic trinomials, these are definitely a quadratic trinomial because it's in this shape of standard form, ax squared plus bx plus c. Now I know these are a's and not x's, but that's neither here nor there. All right, so ignore the fact that these are not x's. It's just these are your variables. X is your variable here, okay? So in order to factor these quadratic trinomials, what I use is the product sum method. All right, so the product sum method says we are going to be looking for the product of a times c and then the sum of whatever our b is. Okay, so what does this mean? It means we are going to take, again, the product of our a, which in this case is 1, times our c, our constant, which is 20. So 1 times 20. And whatever our b is going to be the sum. So in this case, our b is our sum, which is 9. And we are now looking for the factors of 20 that add up to 9. Factors meaning the two numbers that you multiply together, they give you 20, hence product. Sum is addition, add up to be 9. So we know that the factors of 20 that add up to 9 are 5 and 4, all right, or 4 and 5, doesn't matter, right? And we know that 5 plus 4 is definitely 9. So every time you're able to use this product sum method, we know that when you factor these quadratic trinomials, it's always going to factor to be this shape. It's going to be parentheses and parentheses, two sets of parentheses. Your variable is going to be in each one, so for sure. And it will be plus or minus, again, depending on what these factors are. And it will be some number. Again, I don't know what this number is going to be. I'll use some number w, and then maybe perhaps some other number z, something like that. So it's going to have this shape to it. Okay, so you're going to have your variable here, your variable there, whatever your variable is. In this case, it's a, plus or minus whatever the number you get here, and plus or minus whatever the number you get there. So whatever two numbers you get for the product are going to be the values that go inside the sets of parentheses. All right, and since they're both positive here, these will both be plus signs. If this were a negative, then you would have a negative here. If this were a negative, then you'd have a negative there. Okay, so we know that this is a quadratic trinomial. We have used the product sum method to figure out what your values are, what your w and your z are, so to speak. So we are going to set up our two sets of parentheses. We're going to put our variable in each one, a here and a there, and we're going to fill in the rest with the values that we found from our product sum method. So we have now fully factored this quadratic trinomial, and you could always double check your answer by taking the product here. If you did the FOIL method, you would get a squared, bam, 5a, 4a. When you add those together, you get 9a, and then 5 times 20, 5 times 4 is 20. So factoring using this product sum method, some teachers used to do like guess and check and things like that. I try not to do anything that deals with the word guess, right? I want to be able to systematically get my answer every single time. So this product sum method allows me to do that. Obviously, the better you are at figuring out what your multiples are and what your factors are, the better you are at doing this product sum method. But that's something that you can definitely practice. All right, so let's take a look at this one now. Again, it is a quadratic trinomial. It's in that shape of ax squared plus bx plus c, and I know that these are b's and not x's. So we are going to, again, complete this product sum method. We know that the shape of our answer, if it's factorable, will have two sets of parentheses, and it will have our variable in each set of parentheses. Okay. So the next thing that you want to consider here is that your product is positive. So you are going to have this 1 times 10, which is going to be 1 times 10, which is obviously 10. And our sum here is negative. So our b is going to be -7. The only way to get a positive product but a negative sum is if both of your factors are negative. That's the only way it's going to happen. Negative times a negative is a positive, and then a negative plus a negative is going to be a negative. So we know that our factors are both negative here because we have a positive product but a negative sum, and the only way that that happens is if both values are negative. So we are now going to figure out what those factors of positive 10 are. That will add up to -7, and of course that they are -5 times -2, and -5 plus -2 is definitely -7. So these are the factors that are going to fill in our sets of parentheses. So -5 and -2. And if you check your answer by using the FOIL method or the box method, you would still end up with, get right back to this b squared minus 7b plus 10. All right, so we'll take a look at this one now. So again, I'm going to recognize that this is in that form of ax squared plus bx plus c. So again, if it's factorable, we will have two sets of parentheses. Our t will be in each one. And we also can take a look at this and say, all right, well, this time our product is negative, right? 1 times -5 is -5, and our sum is positive. Our sum is 3. Well, the only way that you can get a negative product is to multiply a positive times a negative. So you know right off the bat that one of them is going to be positive and one of them is going to be negative. That's the only way you get a negative product, is a positive times a negative or a negative times a positive. Doesn't matter which order, right? Because again, multiplication is commutative. So you put your plus here and your minus there because you have a negative product. And again, the only way that that happens is a positive times a negative. So now you're looking for your factors of -5 that add up to 3. And the only factors of -5 are 5 and 1, right? 5 is a prime number, so it only has 2 factors. And it doesn't matter how you slice that, you're never going to get 3 out of this. So this is known as prime. You cannot factor this because you cannot find the factors of -5 that add up to 3. So this right here is a prime example. We actually cannot factor this, so we can get rid of this altogether. This can't be factored, so we say that it is prime. All right, let's take a look at this one. This one is more interesting because we have a second variable that's invited to the party. It's not just p's, we also have q's. The thing that makes this interesting is this. This is a quadratic trinomial with respect to p in this direction. It is ax squared plus bx plus c, right? So if you just had this p squared minus 5p plus 6, it's a quadratic trinomial with respect to p. Well, it's also a quadratic trinomial with respect to q, but it's in the wrong direction, right? You have your q squared here, and then you have your plus, you have your q there, and then plus 1 or minus q, it doesn't matter here. So you have your ax squared plus bx plus c with respect to q. So you do have a quadratic trinomial with both of these variables. They're just not in the right order, at least the q's aren't. So here's what I do, is once I recognize that I have the quadratic trinomial in both directions, again, p squared, p, and then a 0 term, a q squared, a q, and then a 0 degree term, what I do is I completely ignore the q's for a minute. I'm just going to factor this quadratic trinomial, ignoring the q's altogether. So I'm going to use the product sum method. Again, I'm going to have my two sets of parentheses. I'm going to have my p in both of them. So there we go, there we go. And I'm going to use this product sum method to figure out what numbers belong inside here. So again, my product is 6, and my sum is -5. And again, once we recognize that we have a positive product but a negative sum, we know that both of these factors are negative. We know both of the factors are negative because the only way you get a positive product but a negative sum is having both of these factors negative. So that means that it's going to be -3 and -2, because -3 plus -2 is -5. Okay, so we will put our -3 in, and we will put our -2 in. Now that we have done this problem as if these q's were not there at all, what we're going to do is put the q back into these problems. And we know that everything here is backwards, which means our q is going to be here with our numerical terms. If the q's were over here, and I'll show you a quick example of what that would look like, then the q would go right next to p, all right? Again, I'm going to show you a quick example of that in 1 second. So because q is at the end here as a quadratic, that's why it goes along with the numbers, okay? Again, I find this to be the easiest way to factor these quadratics with multivariables. I can still use my product sum method. I just ignore the q's and then put them back in where they belong at the end, all right? So if you had a problem like this, so let's suppose you had x squared y squared plus 3xy plus 2, something like this, right? Again, you have a multivariable situation. They are both quadratic trinomials with respect to their given variables. So x squared, x, and then a 0 degree. Y squared, y, and then a 0 degree. So these are both quadratic trinomials. You can still ignore the y's, but they're both going in the same direction. You have this squared, the degree 1, and then the degree 0. You have the squared, the degree 1, and then the degree 0. So with this problem, if you were to factor this using the product sum method, again, just ignore the y's for a second. Let's suppose you had x squared plus 3x plus 2. If you were to factor this, you would get x here, everything's positive, so plus. And then again, the factors of 2, so product sum, factors of 2 that add up to 3 are 2 and 1. So 2 plus 1 is definitely 3, so we are good there. So this is 2 and 1. But because the y's are going in the same direction as the x's, the y's go with the x's this time instead of with the numbers. So over here, where the q's were going in the wrong direction, that's why the q's went with the numbers. Over here, the y's are going in the same direction as the x as far as descending order. We're going to put the y's with the x's over there. And if you FOILed it out, you would see that you would get right back to this guy. All right, so let's take a look at this one now. So this goes back to what we had talked about in the previous video of before you do any other style of factoring. We know that we're in a section where we're factoring a trinomial, but we have a common factor here. We can factor out a 3a from every single one of these. So we need to do that first. We really should do that first. So I'm going to factor my 3a out, and that's going to leave us with a quadratic that's going to be a squared plus 4a minus 5. And what happens now is you have this quadratic trinomial inside here that you need to factor. So this is going to be 3a. And again, when you factor this quadratic trinomial, it's going to be two sets of parentheses. Your a is going to be in each one. Since your product is negative, you know that one of them is going to be positive and one of them is going to be negative. So all I've done here is just set myself up to do my product sum method. So product sum, my product is -5 and my sum is 4. And I know that my product, again, one's positive and one is negative, and it's going to be +5 and -1 because 5 plus -1 is 4. So this is going to be +5 and -1. Now we have completely factored this quadratic trinomial. It looked at first glance that we had one that for the first time had an a value that was not 1, but you can see here once you factor out that common factor of 3a, our a value, again the coefficient of your squared term, the a, is 1 here. All right, so now we finally have one where our a value is not 1. Okay, so we're going to do this one. There's a couple of ways to do this, so I'll show you both ways. All right. Number one, our answer is still going to have two sets of parentheses with our variable in each one. So we are still going to have our two sets of parentheses, and our variable is going to be in each one, k and k. We have a positive product but a negative sum, which means both of these factors are negative. Again, I'm just setting myself up for success here. And I'm going to do the product sum method, product sum. And again, it's a times c, which is going to be 60, a times c. This is the first time we've actually had to multiply by some value because when a is 1, it doesn't change anything. And our sum is 19, or -19 in this case. So we are looking for the factors of 60 that add up to -19, and again both of them have to be negative, so it's going to be -4 and -15. -4 times -15 is 60, and -4 plus -15 is definitely -19. So we put them in. So again, everything here is exactly like it was before, and we're just putting these in here and we're good to go. Except if you FOILed this, you would never get back to this trinomial here. You're missing things, right? And the reason for that is because we multiplied by 6, which scaled these guys up 6 times bigger than they should. So what we do, and again, this is what I do to factor, and I'll show you a different way if you don't like this, is we've got to scale these back down. Okay, we're going to scale these back down. And what happens is this becomes a fraction that can be simplified. So this is going to be k minus, k, actually I need to write the k minus 2/3. That's the simplified version of 4/6. And this one's going to be k, these are both divisible by 3. This is going to be 5/2. And you're still thinking, hey, well, if I FOIL this, I'm still not going to get back to this guy. And the reason is this 3 and this 2 are supposed to be the coefficients of their respective variables. So this is going to be, as a final answer, 3k minus 2, and this one's going to be 2k minus 5. So this is one way to factor this quadratic trinomial. This is the way that I factor it. You don't have to do it this way. Another way to do it is to factor by grouping, okay? And I'll show you that over here on this side of the screen. So it starts off the same way. You start off by using this product sum method to figure out what these numbers are supposed to be. And what we do is we split this middle term using these values. So this is going to be 6k squared minus 15k minus 4k plus 10. So again, all I did was rewrite my middle term, this negative 19k. I rewrote it so that it was using these two factors that I found using the product sum method. And what you can see now is we have a 4-term polynomial, and we learned in the previous section that you can factor by grouping. So I'm going to, let's see if I can change the color here. Let's see. Color. There we go. So I'm going to factor by grouping here. Factor by grouping. Factor by grouping. And put a little plus sign there like we learned in the previous one. And you can see that you have a common factor here of 3k, right? You can divide both of these by 3k. So 3k comes out, and that leaves you with 2k minus 5. And you can see that right here, that this 2k minus 5 is exactly what we're expecting to get. And you can see a 3k there and a 3k there. So things are coming together pretty well. And then over here, you've got negative 4k plus 10. So I'm going to factor out a negative 2. So that way I can get my signs to match up. So 2k minus 5. And we have exactly the same stuff in both sets of parentheses, which is what we need in order to factor by grouping. So again, we have the same binomials in both sets of parentheses. So that's going to give us 2k minus 5, and that's going to give us 3k minus 2, which is exactly the same that we have here. So it doesn't matter how you do this, whether you want to factor by grouping or whether you want to use this product sum method and then divide by your a value. Totally up to you. Do whatever you feel is most comfortable, whatever you're going to get the right answer the most oftentimes. Again, you're going to get the same answer either way. So whatever floats your boat. Okay. All right, let's continue. So let's do this one now. So everything here is positive. So maybe I'll do the product sum method again, and I will show you the factoring by grouping. Most students like that method more, so I'll just do that. So we've got 30. Again, A times C is 30, and my sum is 17. So I need my factors of 30 that add up to 17, which of course are 2 and 15. So 2 plus 15 is definitely 17. So if you're using the factoring by grouping method, you just rewrite your middle term. Instead of 17x, you write it as 15x plus 2x plus 3. Again, you just doesn't matter if you write the 2x and that's not going to change anything. That it should be fine. So we just rewrote our middle term, that 17x, so that it's using the two factors that we found. And now we factor by grouping. So we group, which these have a 5x in common, which leaves you with 2x plus 3. And then over here, you group these, and they don't have anything in common. But again, you still need to factor out a 1. I had mentioned to you in the previous video that there's still a time where you're supposed to factor out the 1, and this is definitely it. So we factor out that GCF of 1, and that leaves us with 2x plus 3 inside the parentheses. No surprise there. And now we have the exact same binomials in both sets of parentheses. So that will give us 2x plus 3, x, and the 5x plus 1, and the 5x plus 1. There it is. And if you were using my other method, I'll just show you real quick. So if you said this was going to be x plus 2 x plus 15. Again, just setting up your sets of parentheses. Your a value is 10, so what you would do is you would scale this back down. So that would be x plus 1/5 and x plus 3/2. And then these denominators become the coefficients. So it becomes 5x plus 1, and this becomes 2x plus 3. So you'll see right here and right there, you get the same answer no matter how you do this problem, so long as you are not making up your own rules or anything like that. All right, so we'll do this one. Again, using the product sum method, we'll start off using that every time, no matter whether you're factoring by grouping or using the setup method of using your two sets of parentheses. So this is going to be negative 30 and positive 13. Since we have a negative product, we know that one's positive and one's negative. We know that. You have to commit to understanding that one of these is positive and one of them is negative, absolutely 100%. So that means that this is going to be 15 and this is going to be negative 2, right? Because 15 minus 2 is 13, all right? So maybe we'll do the factoring by grouping one more time just so you can get the hang of that. So 6r squared plus 15r minus 2r minus 5. Again, split up your middle term using these two factors that we found. And when you factor by grouping, again, you group these first two, group these second two, and put your plus sign there. You see that they have a 3r in common. They're both divisible by 3, and they're both divisible by r. So that gives you 2r plus 5. And over here, it's almost exactly the same, just the signs are not matching up. So we've got to factor out that negative 1, which gives us a 2r plus 5, and that's exactly what we have there. And our final answer is 2r plus 5 and 3r minus 1. And once again, I'll show you real quick what would happen if you tried to use my other method. So if you did this, you would have r plus 15 and r minus 2, which you would then scale back down by 6 because your a value is 6 this time, which is going to give you r. These are both divisible by 3. You get 5 over 2. And over here, they're both divisible by 2. You get 1 over 3. You're just simplifying these fractions. And now the denominators become the coefficients of the variables. So it's going to be 2r plus 5, and it's going to be 3r minus 1, which, bam, that's exactly what we have right here. So it depends on whatever you like most. I tend to do this one because it's a little bit less writing. And obviously, like I kind of skip this step right here. I recognize that when I simplify this fraction, the 3 is going to go there. And when I simplify this fraction, the 2 is going to go there. So it just skips one of the steps from the process. All right, same sort of deal is going to happen here. Again, you have this multivariable situation. So let's just rewrite this so that we have 6m squared plus 7m minus 5. We're just going to ignore the n there, just like we did with the previous problems. We're going to use our product sum method, which is going to give us negative 30 and a sum of 7. So we are looking for our product of negative 30, which means one's positive and one's negative, and it better add up to 7. So we've got factors of 30 would be 6 and 5, 10 and 3, and that's our winner. So we've got 10 and 3. And remember, if you're not sure what numbers belong here, like which one of these is positive and which one is negative, the bigger of these two numbers is always going to follow the sign of this guy. So since this is positive and 10 is bigger than 3, they're going to follow each other, all right? Because obviously 10 minus 3 is positive 7. Or if you switch the order, if you made this 3 minus 10, that would be negative 7, and now the signs are not matching. They have to be perfect, okay? So these are our factors. So I'll just use my other method, which is going to be m plus 10, m minus 3, and I'm going to scale it back down by 6 because again, our A value is 6. So scalar back down, which is going to be, again, these are both divisible by 2. So that will be 3m plus 5. And these are both divisible by 3. So this will be 2m minus 1. Again, I'm just simplifying the fraction. I told you I would skip this step of rewriting the simplified fraction. So that's why I get my answer a little bit cleaner. And then last but not least, don't forget to put your n back in the problem. So put n in, put n in. Now we are done. All right, let's do a couple more of these. For me, what happens when our A value here is less than 0, what I generally do is I factor out a -1. I only like to do these problems, again, this is just a matter of preference for me, when my A value is 1. So what I do is I factor a -1 out from the whole problem, and that's going to give you 2p squared plus 5p minus 12. Now, again, this is a matter of preference for me. So I factor the -1 out to make my A value positive, and then I proceed from there. I'm going to use my product sum method of saying A times C, which is -24, and then whatever my B is, which in this case is 5. So we are looking for the factors of -24 that add up to 5, which are +8 and -3. When you multiply these together, you get -24. And I'm going to use those values, so don't lose track of that negative. This is going to be our 2 sets of parentheses. Our P is going to be in each one, plus 8 minus 3, and we'll close that bracket. And then last but not least, our A value here is 2, so we've got to scale it back down by 2. So we've got -1. This is going to be P plus 4. This will end up being 2p minus 3, and we are now officially done with factoring this problem. All right, so let's continue, do a couple more. This one is interesting because, again, we have a common factor. We've got to always look for that. Don't be suspicious for every problem. Make sure that you are taking a look to see if you can take out a value from all of them. So we can divide everything by 2m. So I'm going to do that. So 2m is going to come out, and that's going to leave us with 4m squared plus m minus 3. And now I have a quadratic trinomial left inside these parentheses. I'm going to use the product sum method to figure out what numbers I need. So this will be -12. And this will be +1, which means my factors are +4 and -3. So 2m, and then I have my 2 sets of parentheses, bam, bam. And that's going to be m plus 4, m minus 3. And then once again, don't forget to scale these back down if you're using this method. If you're using the factoring by grouping method, this isn't as critical a step because you're just factoring by grouping and it's taking care of itself. But if you're using the method that I'm using right now, you've got to make sure that you're scaling back down your factors. So m plus 1, and then 4m minus 3, and we are done. So this is where that factoring using substitution is definitely going to be helpful. So you look at this and you say, all right, well, this looks like it's a lot more complicated because instead of just having, instead of just having x's inside here or p's inside here, you have this z plus 5 and another z plus 5. But the good news is that these are the same. Z plus 5 and z plus 5 are exactly the same. So what I'm allowed to do is use something that's called u substitution. We call it u substitution because we are going to use the variable u. So this says that this z plus 5 and this z plus 5 have some value. They're equal to something. We don't know what that is because we have no idea what z is, but it's equal to some value that I will call u. So what I'm going to do now is I'm going to replace these z plus 5s. I'm going to substitute it with a u and see what happens. So that's going to give us 8. Oops, I don't know what happened there. A little slowing. So 8u squared minus 2u minus 3. So again, anywhere there was a z plus 5, I took it out and replaced it with a u. Z plus 5, took it out, replaced it with u. And now I can see that I have a pretty clean quadratic trinomial that I will factor, okay? So product sum method of factoring says I'm looking for negative 24. That adds up to 2, or negative 2. So that will give us negative 6 and positive 4. So maybe as a way to kind of shake things up a little bit, I will break this up and use the factoring by grouping method. So 8u squared, and that's going to be minus 6u plus 4u minus 3. And when you factor by grouping, so factor by grouping, bam, 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 you have a 2u that they have in common. So when you take it out, you're left with 4u minus 3. Over here, you have a 1 in common. So when you take it out, you're still left with 4u minus 3. And last but not least, you have this 4u minus 3, and then this 2u plus 1. So this would be done if our variable was u, but of course it's not u, it's this z plus 5, right? This was just a temporary placeholder. So what we have to do now is put our z plus 5 back into this. So this is going to be 4 parentheses z plus 5 minus 3, 2z plus 5 plus 1. And now I've got to distribute and simplify. So that's going to give us 4z plus 17, because 4 times 5 is 20, minus 3 is 17. And this is going to be 2z plus 11. And now we are completely done. All right. So like I said, I won't hammer you guys with too many of these, but this is useful, and it's definitely a useful technique for those of you who are going to be continuing on your math journey into calculus and beyond. All right, so that will close off this video. I'm going to try and chunk out chapter 5 as much as possible, so that way you can take the careful consideration that it needs. As I mentioned in the previous video, chapter 5 is super, super critical to success going forward. All right, so hopefully you found this video to be helpful, and I will see you at the Q&A sessions.